Hey there, hello, and welcome back for day 275, me doing Daily LeetCode challenge that reached 1 year's worth of green contributions here on GitHub. So today's one is for April 17, 2025, and without further ado, let's get straight into it. Okay, today we get LeetCode easy, perfect, 2176, count equal and divisible pairs in an array. Another counting problem, man. When is it gonna stop? Okay, given a zero index integer array nums of length n and an integer k, return the number of subpairs I, j, where 0 such that and I times j is divisible by k. Okay, and I'm guessing that nums is, yeah, so it's 100. Okay, so here we can just do for I in range length of nums, for j in range I plus 1 length of nums.
Yeah.
Here we'll just n is equal to length of nums, and here we'll say, or here we can just do sum of nums of I equals nums of j, and I times j modulo k equals 0, I in range n is equal to length of nums, j in range I plus 1, comma n. And there we go.
Okay.
Alright, we should probably put this in parentheses.
We still need to know which SharePoint and which data we need to put in, so we can add it. Okay, sounds good.
Maybe this just needs to be in a list.
Okay, thanks. Bye-bye.
No, assignment expression cannot be used in an iterable expression. Okay. So here we'll just get rid of this. I'll just replace this with length of nums. That's completely fine. Okay. Alright, that's accepted. Let's submit. And there you go, bada bing, bada boom. Completion streak 275 days. Consistency is key. See ya tomorrow. Okay, 35 ms. People have a faster solution. Okay, so maybe there's a way to do this in O of n time, right? Okay, so this is a one-liner solution. Maybe we can do something like n is equal to length of nums, res is equal to 0 for I in range, for I comma num in enumerate nums. For j in range I plus 1 comma n plus or equal to num for nums of j and I times j modulo k equals 0. Return res, right? So this would be the non-one-liner solution. Right? Maybe this is a little faster. Yeah, still 35 ms, so okay. So maybe there's an O of n way of doing this, right? We should probably try to figure that out. I times j is divisible by k is very interesting. Yeah, you can't sort because it's like the order matters. It's like you can probably use this to skip a lot of results, right? Maybe it's like you could probably do like, you know, step 1. Map all nums to their indices. And for num in D, step 2, each num j in range length of indices. And enumerate indices range I plus 1, bless you. Here we'll say index I times index j, okay, equals 0, right? But this is still O(n) squared. As equals 0. This is still an O(n) squared solution. Yeah, so this is accepted. Oh, okay, but it's much faster at least. Okay, there's that at least. So yeah, I guess this is a little bit of a faster solution. It should still be O(n) squared worst case, but that way at least, like, you know, you kind of group it by number, so it's like you only have to check for this condition they're on. Makes things a little bit faster. One-liner solution. Tac, tac, tac. Res equals 0. And return res. This is fine. Yeah. I wonder if there's a better way of doing this. I times j is a little bit awkward. You could probably just do things where it's like, okay, if I have an I and I want things to be divisible by j, then it's like you can do something maybe a little cooler, and like only look at possible indices that would make it work, right? If you're at index 1 and k is equal to 3, right? But if k is 1, yeah, k can be 1, so in the worst case when k is 1, it's like, yeah, right, like everything is divisible by 1. So you can't really, right. Yeah, plus it's a LeetCode easy. It's not meant to be like, you know, think too hard. So there we go. We'll just leave it at that. So nevertheless, as always on my videos, I do a quick recap of how to solve problems. So for this one, here I have a little bit more of an efficient solution, but I think it's just efficient in practicality. This is probably still just O(n) squared. So in those terms, you could just understand the O(n) squared solution. Basically, we want to get the number of pairs ij, where I is less than j and obviously in bounds, such that nums of I is equal to j, nums of j, and I times j is divisible by k. Well, here's what we can do. You can just say, okay, we'll get a result, we'll set it equal to 0, and we'll say for I in range, length of nums, right? Then we'll say for j in range, we need that j to be greater than I, so we'll do I plus 1 all the way up to the length of nums. We'll say, is it valid, right? If it's valid, if and only if it is the case that nums of I is equal to nums of j, right? And that I times j is divisible by k, which we can check by doing, is it the case that I times j, when you, the remainder after you divided by k is indeed equal to 0, making it divisible by k, right? So it's valid if and only if the numbers are equal, and I times j mod k is equal to 0. In that case, we'll say if is valid, then we'll add 1 to our result and return our result, right? And if we run something like this, we'll see that we get a beautiful accepted down here below, and we can press submit, and it's just a very nice, easy brute force to this problem, right? And that's exactly what my one-liner solution does here up above. It's just like, return the sum of the cases where nums of I is equal to nums of j and I times j mod k is equal to 0 for I in range length nums, for j in range length I plus 1 all the way up to length nums, right? So it's just the same thing in one line of Python code. Now, a thing that I did to be a little bit more efficient, here you'll realize that when I submit, I get a little bit of a faster runtime, but it's still technically U of n squared, is here I first of all map all the numbers to their indices, right? Because we only care about numbers that have the same value, indices where the values of those indices are the same number, right? So I might as well group each number into like, its list of indices for that number, right? And then for each pair of indices for each number, I can then check like, okay, how many of the pairs are actually divisible by k, right? Maybe if I sort the pairs, I can do something more efficient, but at the end of the day, there's maybe a better way to do this problem asymptotically. I just don't want to think about it too much, and so I have a technically n squared solution, but like, practically this will be a bit more efficient, because here what I'm going to do is I'm going to have a hash map that for each number, nums will point to all of the indices whose value is that number, and so that way I can go through, okay, every single list of indices in d.values, because these will map as indices to the same value in nums, so we'll already have essentially this condition checked, because essentially each element in d.values will be a list of indices where, like, if you have index I and j in a list of indices, nums of I is equal to nums of j. So then we're just like, okay, given that list of indices, just count the number of pairs where the product of any two indices is divisible by k, right? So for I, index I in enumerated indices, for j in range from I plus 1 to length of indices, it's like, okay, if index I times indices at index j is indeed divisible by k, so modulo k is equal to 0, then augment res by 1, and again, do that for every single list of indices that's mapped to each unique number inside of d.values, and then return a result at the end, and there you go, bada bing, bada boom. You just have a little bit of a more efficient solution, but again, probably if there's better than an n squared, then this is not an optimal solution, but this is just what I did for this problem. And yeah, but otherwise, that's pretty much it for this video. If you did find this for enjoyable in any way, shape, or form, I'd highly appreciate if you left a like or a comment, but otherwise, I'll catch you next one. So till then, ciao, ciao, my friends. Bye-bye.